How do? My name is Andrew Hancock and I am a VMware technical architect from Yorkshire in the United Kingdom. I have worked with VMware since their birth in 1998, so that has been over 24 years I've been working with the VMware product catalogue. Some of my close colleagues may say, if you cut Andy in half these days, it reads VMware like a stick of rock from Blackpool Pleasure Beach. I have now written 130 articles and recorded 10 hours of VMware vSphere videos for Experts Exchange and received 41 Experts Exchange awards over the last 10 years working with the Experts Exchange community. I am currently the overall #1 point earner in the Hall of Fame at Experts Exchange. I am honoured to have been accepted into the VMware vExpert program since 2011 and more recently a VMware vExpert Pro for the last 3 years.
Okay, so welcome back to another Hancock's VMware half hour, which could actually turn into 60 minutes, so stay tuned. So this is a continuation of the last video that we did where we actually created our cluster, and I've been pondering with the Towers of Hanoi conundrum of the EVC and the logical method that we have to go through and the hoops that we have to go through to move ESXi 007 into our EE cluster, which has you remember, it has that EVC baseline of Ivy Bridge. Now, of course, you don't have to use an EVC baseline, but if you don't use an EVC baseline, then you will not be able to live migrate vMotion virtual machines from host to host. There are some articles and debates of shiny new servers, putting them with older servers in the same cluster, putting an EVC baseline then turns off all your lovely new shiny instruction sets on your new CPUs. And all I would say really is that you need to look at your virtual machines to see whether or not your virtual machines need the use of the newer instruction sets. You know, I have come across a few requests from services that require specialist virtual machines that require specialist instruction sets in newer generation CPUs, and an EVC baseline would obviously turn those all off. So there are questions as to whether or not that you mix old and new in the same cluster, or whether or not you have a cluster of new hosts and a cluster of old hosts and then migrate the virtual machines between the two. Obviously you can go from an older instruction set to a newer instruction set, but you can't go from a newer instruction set to an older instruction set, if you follow me. So for instance, I'll give you an example. If I've got a virtual machine that's actually running on an Intel Ivy Bridge generation CPU, that can be live migrated to a host that's got an Intel Haswell set running on it, because the virtual machine guest will only be using the Ivy Bridge instructions. It won't know to use the Haswell instructions until the machine's restarted. Of course, this doesn't apply to cold migration. If the machine's off, you can do it. So I've been sort of kind of puzzling about the environment that we have here in front of us, and how on earth can we drop that host in there where I've currently got 3 virtual machines that are currently in use. Now, if we take Sawtail, for instance, that's our DNS server for the lab. If we turn that, we can currently move that host, virtual machine, sorry, into that cluster because it's currently running on an Intel Haswell instruction set. The same with VMware vCenter Server 7. We can't move that either. And we can't obviously move VLab NAS either. Now, in this particular lab environment, things are a little bit more awkward because Lab NAS is actually running on local storage in this server only. So I can't move that virtual machine off ESXi 007. It has to stay on ESXi 007. I can't move ESXi 007 into that cluster without that machine being turned off. So my plan, and you may have noticed, okay, the machine is relocated now. Swordtail and VMware vCenter Server 7, they were on our NAS. They were on this NAS here. I've migrated both Swordtail and VMware vCenter Server 7 temporarily off our NAS back to our shared storage. That's back to our local storage. And there's a reason why I've done that, because what I'm going to do, I'm going to shut down this NAS. I'm going to turn it off. Again, I can't cold migrate it because it needs to stay on the local storage. Now, this is really specific to the lab environment that we have here, but it does actually go to show the hoops that we have to go through to do this. So I've just shut down VNAS and I've turned that off. And that will go down shortly. And I'm going to show you one of the later features that we have available to us in vSphere 7. I think it's popped up in vSphere 7. I don't think per VM EVC or EVC VM was available. Okay, so that machine is now off. So if I look at the configuration for that NAS, and I look at VMware EVC, and it actually turned around at the moment, tells me that VMware EVC is disabled, and I click edit and I enable EVC specifically for this VM. This isn't host, this is per VM. So I can do, and I can limit the instructions for that particular VM to a specific instruction set. So if I actually say, well, I want to limit that to Intel Ivy Bridge generation, please, thank you very much, click OK. Now, the fact that I've specifically stopped that virtual machine using any instructions beyond Intel Ivy Bridge, when I drop this host into that cluster, which is currently set for Ivy Bridge, I shouldn't have any issues. And I'm just going to wait to see when that NAS comes back up again. Shouldn't take too long. Obviously not playing ball at the moment. Might get there shortly. Okay, so as you can see, that instruction set change that's been made to this virtual machine has not caused any difficulty for this particular virtual machine. Just wanted to check that everything looks okay. So, just to recap, I've actually edited the settings, configured rather. So now we're actually running a CPU mode of Intel Ivy Bridge generation for this particular machine. So I should be able to drop that into that cluster with no issues. However, of course, I've got Swordtail here and I've got VMware vCenter Server 7. That's our DNS server for the lab, and that's VMware vCenter Server 7. If I turn that off, then obviously I don't get any of this here to be able to configure. So what I plan to do is, we've now got our NAS back up and running. I'm going to, again, I'm going to migrate Swordtail back to our NAS, and I'm going to migrate vCenter server back to our NAS. So they are migrating. So I'm migrating, as I said, I've migrated them off the NAS because I needed to turn it off because I needed to change its EVC baseline. And its EVC baseline is now running Ivy Bridge. So my plan is I'm going to wait until these get migrated to NAS storage. I'm then going to power them off, and I'm going to power off VMware vCenter Server 7. And I'm going to remove Swordtail, and I'm going to power off Swordtail. And I'm going to power off Swordtail, VMware vCenter Server 7. I'm going to remove them from the inventory of this particular host. Because they're on shared storage, or they will be on shared storage, it's currently migrating. I'm then basically going to add them to the inventory of ESXi 009. Now I won't be able to do that through VMware vCenter Server, but I will be able to connect directly to ESXi 009. Well, I'll tell you what, I'll add Swordtail to 009 and I'll add VMware vCenter Server 7 to ESX 011. So they're migrating to shared storage. The shared storage is currently presented to both these hosts in a Ivy Bridge EVC. I'm then going to add Swordtail back to 009. I'm going to add VMware vCenter Server 7 back to 011. I'm going to power them on, and when VMware vCenter Server 7 comes back up again and basically just refreshes its inventory, it will actually show that that is now running on there. And then finally I can drag and drop ESXi 007 into the EE cluster. So that's my thinking. We'll see later whether or not that we can do that. And in the meantime, what I'm going to do, I'm going to disappear. I'm going to go and get another Java, another espresso, and I'll let this carry on. I'll turn off the mic and I'll turn off the cam, and you can watch a migration. Storage vMotion. We're currently migrating 2 virtual machines with no downtime between a local data center, a local data store, and a piece of shared storage, NFS storage, which we've set up previously. So there you go. So I will be back shortly. Is that we want to drag and drop that into the EE cluster there, but we can't do that because that machine's currently powered on and it's currently running under an Haswell instruction set, and we can't move that host with that powered on. So we've powered that off, and here you can see it's powered off. So there's always a reason connect directly to the host. And I'm now going to unregister, not delete. I'm going to unregister this virtual machine from that host. Okay, so it's gone. So that's the only virtual machine we've got currently running on here now. And I'm going to go to our... number 9. Did we say we were going to add it to number 9, or were we going to add it to number 11? We'll add it to number 11, because I did say that we we're going to add one to one and one to the other. So there's always a good reason that we can, if we want to do some troubleshooting things, we can connect directly to the hosts. I wouldn't generally recommend it if you're managing it from vCenter Server. Okay, so we've got one virtual machine currently running on a host, which actually is the cluster services virtual machine, which is deployed. You might see these occasionally hanging around. So I'm now going to look at my storage. Here's my storage that we presented earlier, and I'm going to look at the data store browser, and I'm going to register this VM. It's been registered successfully, so we now have 2 virtual machines, and I'm going to power that on. And that's going to start booting up shortly. That could take a while. Okay, so just to recap, we powered off VMware vCenter Server 7. We removed VMware vCenter Server 7 from the ESXi 00 host by basically going to it directly. We then browsed the data store and we manually added it back to this particular host. And when vCenter Server 7 powers up, updates its inventory, updates its hosts, it will then sort itself out where it's actually running. So let's just go back and see where we are. Okay, so we've got a login. Can take, depend upon your storage, it can take between 15 and 30 minutes to come up properly. So I'm just going to see whether or not that we can. See what I'm going to do. I'm going to open up another. That's the old cached version. And I'm just going to open up another interface URL to it. That looks incredibly quick as it's already initialized, and I don't suspect it has. I think it's still thinking about it. And if we okay, so it's got the IP address, it's got its FQDN, that's the right IP address, CPU, but I think it's still initializing. Yeah, it's still thinking about it, although we can probably ping yeah, okay, we can ping it. FQDN's there, but we're still waiting for vCenter Server 7 to start doing its thing. So, okay, this is what I wanted to show you actually, no healthy upstream. This is quite normal observation when you've restarted a vCenter server based on VCSA, that when it's coming up it will say no healthy upstream as it's actually basically starting the services. So we just have to be patient and we just have to wait, and it can take between 15 and 30 minutes depending upon the underlying storage, and as the underlying storage in this particular case is our Synology NAS, which is virtual, which has still not had the tweaks, running under NFS 3, running on spinning Rust, is going to be slow. So I'm just going to basically put this on pause and I'll come back shortly. So just a couple of things while we're actually waiting for vCenter Server 7 basically to get ready. I wanted to show you, and this is what I wanted to have a look at, show you before. You can generally see that once you start up VMware vCenter Server 7 from cold, you will see these big CPU peaks and big memory peaks. Now we are actually using the standard number of cores, 2 cores and 16 gig of memory as defined. I think actually I've probably increased the memory slightly from a tiny, I think the tiny installation is 12 gig, and I've increased it up to 16 because you often see memory exhaustion issues and also CPU exhaustion issues as well, and often you see them when the server actually starts up from cold. And this is what you can actually see here. Memory's increasing, CPU is almost flatline, and generally you notice that eventually when the server's actually ready, this actually drops down. And if we just go back here and go refresh, then we're not going to see anything different than no healthy upstream at the moment. And bottleneck is probably coming from storage. You can see here in real time the utilization obviously of the NAS, but this is the network and this is the underlying NFS storage, and this is the volume here as well. And we can sort of kind of see that these values here really are very, very low, like 2.8 megabits a second and 7.2 megabits a second. You know, it's quite slow, but the bottleneck is clearly on this NAS that we're using. So maybe I basically probably need to make some tweaks, and I might move it later back to our spinning SSD, or I might use one of the bigger NASs here that we've got for this NAS. But how are we getting on? Are we still no healthy upstream? And if we have a little look at this, is our old cached instant, remember? And if we look back at our host, we're still bottled again. So we'll be patient. I say it could take up to 15 to 30 minutes. Is not uncommon. Whilst we actually basically wait for our server to initialize correctly. So I'll be back shortly. Okay, so no healthy upstream's gone, so it's just waiting for a username and a password. Now initially, once you first logged in to VMware vCenter server from powering up, sometimes you can get a few weirdies occurring. So, can you see that we've got a red exclamation mark on number 11? We'll have a look at that in a minute. We've got a warning on ESX number 9 and a warning on number 7, but more importantly, can you now see that VMware vCenter Server 7 is now in this cluster? It's now in this cluster, running under an EVC baseline of Sandy Bridge. Sorry, Ivy Bridge. Intel Ivy Bridge generation. So this machine and that machine are running under an Ivy Bridge installation. So the main goal here was for us to migrate or drag and drop ESXi 007, which is an R730, which runs an Intel Haswell chip on 2 Xeon Haswell chips, and we want to move it into this cluster using an Ivy Bridge generation. We've already set per VM EVC to Intel Ivy Bridge, so all these other machines are off. So we should, without any issue, be able to drag and drop that into the cluster with no issue. But I'm just going to have a look at what this error message is here. Host memory status. That's interesting, because this machine's got 256 gig of memory. Now that could be, let's have a little look at the host memory status triggered alarm, hardware health. Okay, I know there's a power supply that's not plugged in on this particular host. One of these hosts I know has got a DIMM failure, an ECC DIMM failure, that we've not been able to ascertain what the problem is. It's not easily giving up. got a host memory status error, and we've got a power supply status error. So I know what the power supply status is. Anyway, I digress, because that's throwing me off in another direction. If we've got time in the next 3 minutes, we'll have a little look at that. But I want to get to the point whereby we actually drag and drop ESXi 007, which is the whole point of this video. And while we've gone through this whole rigmarole of transferring it to a NAS, back to a NAS, powering it off, changing EVC baselines, and now all I want to do is drag and drop that into that cluster. And can you see how easy that was? So, in summary, what we've actually achieved is the ability to move PowerEdge R730 into a cluster that's using older Intel Ivy Bridge generation CPUs, and we've done some manipulations of powering off vCenter server, removing it from the inventory of a machine, and then adding it to the inventory of another machine, powering on, and you can see that it's not actually basically caused any issues. And now we have a cluster of 3 machines using our Intel Ivy Bridge EVC. So now that allows us to migrate virtual machines in real time, powered up, between these 3 hosts. So that's it for this video. A little bit of a delve into clustering and EVC, adding old and newer hosts with different CPU generations, which can be problematic. But problematic in that you just have to sort of kind of think out the box and come up with a logical Howard of Tannoy solution to moving virtual machines around between hosts, power them off, power them back on, to get to where you want to. Or don't even use an EVC baseline between hosts. Have a new cluster of hosts with all the same CPU generation and an old CPU generation. But if you're trying to make the benefit of all your hardware, then, as I said, you will need to use an EVC baseline. Okay, well, thanks very much for watching. This one's just coming in under 30 minutes. So anyway, all the best, and thanks very much for watching, and please come back soon when we can start looking at configuring vMotion interfaces on our 3 cluster now. So, you know, we're sort of kind of basically bigging it up, and we're becoming more and more production in this lab, and I look forward to you coming back soon. So again, please take care out there. All the best, and goodbye from me.